Kiprotich Kimutai. I am a senior software engineer and CTO at Nexuscale AI, which is a one-point solution for sales teams. We have a database of over 200 million leads. Then you can reach out to those leads through automated emails and campaigns. So that is where the agents come in. Yeah, and today I'm going to talk about AI agents and how Elixir is built for it. I think first we need to talk about the difference between agents and chatbots. So a chatbot is basically reactive, has some memory, maybe conversation history, but not a lot. But you basically send a message, it responds to whatever you're talking about. But for an agent, it's completely different. It's fully autonomous, can act on its own. I normally think of it like someone at work. You have your brain, you have tools, which can be a laptop or your cell phone. Then you have the current context, which is what you know about the current task. So that's basically an agent. An agent has various components. So the major component is the brain. So the brain is basically the LLM that reasons or decides what to do next. Then you have tools. So tools can be different things that can connect to an agent. It can be audio, screenshots, web search. Yeah, you can basically connect anything to an agent. Then we have the context. So context is basically the memory of what the agent has done so far. So why Elixir? The first point is in Elixir, you can spawn very many lightweight processes with independent state. So whenever you need a couple of agents to do different tasks, you can just spawn them as processes. We also have OTP and fault tolerance. So basically you have a supervisor tree that will monitor all the agents, and if anything fails, Elixir can detect and restart the whole process. So we have stateful agents, which is basically a GenServer, because an agent needs to maintain state across multiple steps, and a GenServer is a perfect primitive for this. So it's a persistent callable process that with managed state, basically. And in Elixir, different processes can communicate through message passing, because there are moments that you need to pass some information from one agent to another. For example, if you have an agent that does research about a particular lead, you need to pass this information to an agent that generates an email, for example. So this is basically the GenServer process. So we have the state, which can be short-term state. Short-term state is normally the current context of what is being done. And we have episodic state. Episodic state is normally when you go to Cloud Code and you want to do something, it normally generates a plan. So it goes through that plan, and that is basically stored through the session. And we have a long-term memory, which is normally stored on the DB. So this might be your own preferences, that you have done. Then we have the LLM. The LLM is connected to the GenServer. Then the side effects, which are basically the tools. Then you can stream information to the UI or to another agent. So my architecture is normally very simple, 5 files for everything. We have the orchestrator, which is, I normally have the context, the runner, tools, supervisor, and the brain. So the brain is where the LLM is connected, which is basically the orchestrator, and it dispatches the tasks. Then the runner will now it will now ask the brain, what should I do at this time? So the brain decides whether it's supposed to do a Google search. So it calls that tool to do that. Then when the result comes, it goes back to the brain, decides what to do next. If it's done, we can now stream the responses to the UI. If it's not done, it will just go to the next step that's supposed to be done. Yeah, so this is why Elixir is very good for this, because it's a very simple architecture. You just have 5 files. The brain is normally shared and can be connected to different LLMs, whether it's self-hosted or existing like OpenAI or Gemini. So any capability now becomes a tool once you have those 5 files. You can just add several tools. If you want a web scraper within your implementation, you can add a web scraper, you can add audio, you can add screenshots, file reader, file writer, etc. I'll take you through a simple demo that I have. So it's a CLI agent. Just a sec. Yeah, so it's a CLI agent that has access to different tools right now. So it has access to the web scraper and a bunch of other tools. So there's something I added for audio. So for example, sorry? Font size, okay. Sorry. Oop. Yeah. So we have those tools, and I added one tool which takes the audio, detects whether someone has asked a question, then it does research about the question, then brings back the response. So, for example, if I write listen, so the LLM will be smart enough to know which tool it's supposed to use from that. So, for example, I can try asking a question, what are the components of an AI agent? I hope it works, because nothing ever works on a demo. Yeah, so it did a Google search, got 5 results, then it gave us the response. So that's just an example of that, but we can try many other tool calls that are available. Now there's one big problem, which is context management. The problem is LLMs normally have a context window, and you can hit those limits quickly without finishing the task if you have a long-running task. So the solution for this, which Claude has done, for example, is context summarization. So if you have a long-running task, you summarize the context, then use the summary to continue the current task. But now the challenge is doing that without losing critical state that is important for whatever you're doing. So there's something I have been trying out, which is context graphs. So we can think about them as, so it's a graph agent. A graph agent basically, so instead of loading the full document corpus, for example, or conversation history into the context, so an agent queries Neo4j for the subgraph that is important for the current task, or that is relevant for whatever you're doing. Oh, sorry, I thought I was there. Yeah, that is relevant for whatever you're doing. So every time it just fetches a small targeted slice while keeping the state really small. But now it does not remove the fact that we need to manage state, because the Cypher queries need to be very specific. If you don't have good Cypher queries, you'll end up overloading the state, and you'll have the same challenge. But it's something that I have been looking at and trying to implement in my current projects. Yeah, thank you. I think we can. Any questions?
Reminder to post any questions you have in the SwapCart app, and I'll read them out loud so Kimutai can answer them. In the meantime, since I don't see any, I have a question.
There was a question over there.
What's that?
Someone.
Okay, you can say it, and I'll try and hear it and repeat it.
Can you describe a bit more how text gets turned into a context graph?
Can you explain how text gets turned into a context graph? Yeah. Okay.
I think it's basically similar to how RAG applications work. It does a cosine similarity search from a Neo4j, according to my understanding. Then it gets a subgraph with the specific context that is needed for that current question. Yeah.
And Francois would like to know, is your demo available somewhere? I'm sure everyone would like to see that.
Yeah, I'll share the code after the session. I can open source it, but you can play around with it, add a couple of tools. Yeah.
How can they find it?
Uh,
You could put it in SwapCart, or if you have a website or
yeah,
something like that.
yeah, my GitHub.
What's that?
I can share the GitHub link after this session.
Okay, great.
It's open.
Sounds great.
Yeah.
All right, I have another question. What were the biggest technical challenges? Let's see, just a moment. That's always the question, isn't it? What were the biggest technical challenges you faced when scaling from a prototype to managing 200 million leads in production? And how did Elixir's specific features help you overcome them?
I think that's more of a database question than an agent question. But
Okay.
how we did it is we normalized the tables so that we only have important information that we need whenever someone queries the database. Then we have a bunch of indexes. Yeah, basically indexing the table and normalizing it to avoid having to do some joins. Yeah.
All right, awesome. So be on the lookout for that GitHub link so you can check out that demo later. I got another question. Any suggested client for LLMs like Rec LLM, LangChain?
In Elixir, I think you can use LangChain for your tools, since it's open source and it's pretty nice. But always use open source. I'd not recommend any because it depends with your use case. Yeah, but always use the ones that are open source. Anyway.
Okay, awesome. I don't have any more questions. So let's give another round of applause for our speaker. Would you do one more question? I just got another question in. Yeah. Okay. All right. From Othman. How do you manage non-deterministic tools, like tools that may be calling LLMs themselves or have runtime effects?
That's a good question. So I think if you have non-deterministic tools, you can find a way to, because all these processes run in the background anyway. So you can spawn the agent concurrently because it's normally a loop. So if there's a tool call, it will go to that tool call, then it will continue the loop. So I think it's still fine since it will call an LLM, but later on bring a response, and it can, if it takes a while, it's just fine since we're doing everything on the background. Yeah.
All right. Thank you, Kimutai. All right, we're going to have, another round of applause. 3 round of applause for Kimutai.